I'm sure you've heard of mapping before, but this time it's in Scheme and we are still dealing with lists. Mapping in Scheme and lists means that we're going to apply a given rule or a function to all the data within the given list. In the example that I have for you here, there is a function named double underscore all, and the E means evaluate. So starting from the left hand side, we have the list 1, 2, 3, 4. We're going to give it the mapping of the function double all, which means just that's going to double all the values, and the result will be the double of every single element in that list. And then same thing for if we had created a function increment by 1. Again, we have to create the increment by 1 if we wanted to do that. Now there are some already pre-built, and we just talked about that, functions that are out there in Scheme, but most of the time you're going to have to create your own. An easy way to do this is to pass both the function needed to map and the data or the list itself. In the example that I have for you, I created two very simple functions, double and increment. Also notice they both accept, and this is the important part, one parameter, but that parameter is not a list. In double's example, when I accept one value from the parameter, I am going to just multiply it by 2. So again, x is really just one atom. Same thing for increment. When we move on to doing our mapping is going to use that function for every single atom or element in the list. So that's why we don't have to worry about double and increment accepting lists, because it's going to perform double or increment on every single item in the list. We have define map car function, whatever function we want, and the list. Here's the other beautiful part, is that function is a parameter. I could decide to do a double, I could decide to do an increment, I could decide to raise everybody's grade by 5%. The beautiful part is MapCar has the ability of accepting another set of functions to be able to adapt our new set of data that we want. You'll also notice that within the MapCar function it is recursive, and it's going to do a cons that's creating a new list. It's going to first pull the first atom using car, and then it's going to complete the rest of it by moving down using CDR. And I have the two call examples for you below. But here's again the beautiful part, is that we can create our own functions to change the data how we want, and we can use just one function that'll map all those changes that you want